Today, on how it's made. Turbochargers. Enchiladas. And watches. A turbocharger harnesses a vehicle's exhaust gases to compress fresh air, forcing that pressurized air into the engine's combustion chamber for a turbocharged performance. With it, a small engine can be as powerful as a larger one, using energy that would otherwise disappear out the tailpipe. The exhaust gas turbocharger is an invention that dates back over a century, but in recent years, the concept has literally been picking up speed. Design tweaks and the use of lighter materials mean a bigger boost to engine output, so a small engine can be as powerful as a larger one without guzzling extra fuel. Production begins at the foundry. An overhead sprayer blows sand into the shaped cavity of this box. The spraying action activates a binder applied to the sand. This causes a chemical reaction that solidifies the particles. The worker extracts the hardened sand shape from the box. The shape is called a core. It will be used to mold the inside of the turbocharger's housing. He files down any little bumps and rough edges. He then pipes adhesive around the border of a second sand mold and glues the first part to it to build up the core. He applies a putty-like compound to the seam to plug any gaps. Meanwhile, another worker uses a different technique to make smaller cores. He rocks the box, and this causes sand to flow into a shaped cavity. The sand has been mixed with heat-sensitive chemicals. He aims a flame at an opening in the box, as burners warm it from the sides. This triggers a reaction that hardens the sand inside, so it takes the shape of the cavity. The result is another smaller turbocharger core. These snail-shaped sand cores are now ready for casting. He places the cores in a mold, which is also made of hardened sand. Machinery lifts the bottom half of the mold to the top half, essentially closing the mold. He pours molten aluminum into it, and it flows into the spaces between the cores and the outer mold. The aluminum solidifies in a minute, and the molds tumble onto a conveyor, revealing the cast turbocharger parts. They're connected by hardened flow lines. After separating the parts, they ship them to the turbocharger factory. Here, computerized tools carve and contour the aluminum part to specifications so precise they're measured in thousandths of a centimeter. This is the turbocharger housing before the work was done and after. Using a computerized probe, a technician looks for irregularities. Even minuscule ones will need to be fixed. It's now time to assemble all the parts. The worker inserts a bearing into one end of the iron center housing. He lubricates a second bearing and slots it into the other end. These bearings will ultimately support a shaft with a turbine on one end and a compressor on the other. He adds a metal collar and a third bearing to the assembly. He caps the bearing parts with a metal plate. It will keep lubricant from spilling out when the turbocharger spins. He flips the center housing around and installs a metal heat shield on the bottom. He inserts the shaft and turbine wheel assembly. He installs the compressor wheel on the other end of the shaft. He heats the wheel briefly, causing it to expand, which allows it to be pushed further down the shaft. Once cooled, it shrinks to the shaft for a tight fit. Next, a machine called a vibration sort rig spins the compressor at a high speed as a computer analyzes it for vibrations. Even the slightest tremor indicates an imbalance. The computer also detects the source of the problem, so it can be fixed. He grinds the compressor nose ever so slightly to balance the part. He now nestles the compressor into the curled aluminum housing. It's a shape that's designed to funnel air into the engine. He secures the compressor to the housing with a metal ring. He fits the turbine end into its housing. It too has the distinctive curl to pipe the exhaust gases in the right direction. A blast of air now simulates the effect of those exhaust gases, spinning the turbine to power the compressor. It takes about 15 minutes to build one of these turbos. Once installed in an engine, it's full speed ahead. Enchilada means dipped in chili in Spanish, and true to its name, these stuffed corn tortillas are typically smothered in sweet and mildly spicy chili sauce. First cooked up by native Mexicans centuries ago, enchiladas are an ancient food, but they are definitely not passé. In modern times, the enchilada has become a metaphor for having it all. The whole enchilada means there's no holding back. There are numerous enchilada recipes today. This black bean and veggie version starts with the filling sauce. It's a chili-flavored tomato puree. They add organic corn, a firm variety that's mildly sweet. That means the flavor won't clash with the chili spice. Spiraling blades fold the corn into the filling sauce. The mixing action is gentle to keep the kernels intact. The next ingredient is tofu, diced into cubes. Like the corn, it's a firm type for a more substantial texture. The firm tofu is also quite porous, so it readily absorbs the flavors of the enchilada filling sauce. They green up the sauce with chunks of organic zucchini, uniformly diced with the skins on. Black beans are next, already cooked and with the juices drained. This completes the enchilada filling sauce. They cool it to preserve its thick consistency and overall freshness. And now they're ready to wrap. They pump measured amounts of the black bean and vegetable mixture onto each tortilla. And here the chilling of the filling pays off. A warmer, runnier sauce would spill out and make a mess. But this cool, thick sauce stays where they put it, in the middle of the tortilla. Workers now roll the tortillas around the black bean and veggie mix. There's a trick to this. If the tortilla is rolled too tightly, there could be leakage. Too loose, and the enchiladas could come undone. A perfectly rolled enchilada fits neatly into the trays. They place the enchiladas seam side down in the container. Elsewhere in the factory, they sauté various chili powders in flour and oil. They liquefy this flavorful mix with vegetable broth. Mixing blades blend the simmering ingredients and the flavors intensify. It thickens to a gravy-like consistency. And as one would do with gravy, they strain out any lumps or impurities. What exits the sieve is pure enchilada chili sauce. Next, it flows into a dispenser. The nozzle head is the exact same length as the enchiladas, ensuring complete coverage as the sauce is pumped onto them. The enchiladas are now swimming in chili sauce, imbuing the dish with mild spice. The chili sauce also serves to keep the tortillas moist during cooking. They sprinkle on freeze-dried chives. This herb adds an oniony nuance to the dish. Every few minutes, they pull a tray off the production line and weigh it to confirm that the portion size is right. They churn out 53 enchilada entrees a minute at this factory. Next, it's into the freezer to preserve the enchiladas at Arctic-like temperatures. It's a new day and a new shift of workers. They place the enchiladas on a conveyor en route to the packaging line. It takes just 1 minute to wrap and box 75 frozen enchilada entrees. Technology and humans team up to get the job done fast. Enchiladas have come a long way over the centuries, from a simple meal first whipped up by the Mayans of Mexico to a mass-produced frozen meal. Today, they're consumed in countries around the world. And with these frozen versions, mealtime is no trouble at all. Just heat and eat. The mechanism inside a wristwatch which measures time and moves the hands accordingly is called the movement. High-end watches typically use traditional, very intricate mechanical movements. Such premium watches are made up of a multitude of components, requiring hundreds of manufacturing and assembly operations. Luxury wristwatches are made of top-quality materials, often precious metals. They're crafted with painstaking precision, partly by traditional watchmakers, partly by high-tech machines. The main section of the watch case starts out as a block of metal, stainless steel for this model. A press stamps the preliminary shape, which a computer-guided milling machine then finalizes. Another computer-guided machine drills a hole on the side for the stem and crown, the manual watch-winding mechanism. This tool refines the edges. Next, using an abrasive tool, they manually etch the surface to give it a brushed metal finish. They apply some polishing compound to a felt buffing wheel and polish the entire surface. Certain models undergo a second polishing, performed by a robot. The two other parts of the watch case, the back and the ring around the watch face called the bezel, are made the same way as this main section. To produce the movement, they cut a square brass plate and stamp it into a preliminary shape. This computer-guided mill then refines it to the correct thickness. The next computer-guided machine makes several slots and holes. This part, called the main plate, is the base upon which all the movement's components will be assembled. The milling process leaves behind traces of metal dust and oil on the surface, so the main plate undergoes a thorough washing with water and solvent. Once dry, a computerized inspection device examines the plate from 3 dimensions, verifying that every last detail is precisely as it should be. Then the last machine cuts the final circular shape. The main plate is now technically perfect. Only finishing steps remain. First, to remove tool marks, they sandblast the surface to give it an even, matte finish. Here's what the plate looks like before sandblasting and after. Another computer-guided tool etches tiny circles onto the main plate surface to produce a pearl-like effect. This next component, called the bridge, covers most of the parts assembled onto the main plate, and itself holds a number of parts. After a laser engraves the company name, they fill the lettering with varnish. They put the bridge into an automated machine, which etches a brushed finish and wipes off the varnish. Some varnish residue remains inside the letters, making them more visible. Next, a robot sets a jewel into each hole in the main plate. Jewels are tiny cup-shaped synthetic rubies. Each jewel will hold one of the movement's moving parts in a drop of lubricating oil. After installing 2 barrels containing a spring each, the watchmaker positions 4 wheels. These form the gear train, which moves the hands of the watch. Next, he mounts the auxiliary main plate on top. This sandwiches the barrels and gear train, holding them in place. Then, the escapement, the regulating mechanism. Winding the watch fully coils the springs inside the barrels. The escapement paces the springs as they slowly unwind and turn the gear train. Now a robot takes over, squirting a drop of oil in each jewel. Meanwhile, a laser engraves the watch brand name and logo into the oscillating weight. This component is a heavy metal disc, first stamped in a press, then refined by high-precision, computer-guided. The oscillating weight is an automatic winding mechanism. This weight, located on the backside of the movement, automatically winds the watch as it's on your wrist. Therefore, the more often you wear the watch, the less often you have to wind it manually by turning the crown. The watchmaker connects the oscillating weight to the springs which move the gear train, so that the weight will shift backwards and forwards with any wrist movement, automatically coiling the springs. On the front side of the movement, he screws in the date indicator and the dial. The dial is comprised of 2 brass plates, the top one coated in oxidized copper, with cutouts to show the bottom one, which is painted with this company's secret formula of glow-in-the-dark pigments. Next, a machine mounts the brass hour and minute hands. This operation is automated because applying even slightly too much pressure could damage the tiny, delicate hands. Now for the watch case. After twisting an arched ring, called the bezel, onto the front of the main case, he slides a plastic gasket into it, then positions the main case onto a press. Cleans the crystal, then presses it forcefully into the bezel. The gasket seals the minute gap between the crystal and the bezel, so that water can't seep inside the case. Next, the stem and crown. Then, on the back of the case, the casing circle, a ring that comes between the movement and the case. Here too, a gasket seals the gap to make the case water-resistant. He installs the ring and crystal which form the back of the case. He applies grease so that it twists on smoothly. He closes it tightly with a tool, then the fully assembled case goes off to be tested for water resistance. If it passes, it comes back to the watchmaker to receive the movement. He removes the crown and the case back, cleans the movement, then places it in the case. Next, he squirts grease in the crown hole and reinstalls the crown. This time, because the movement's in place, the crown's stem connects to the two springs, so that turning the crown now winds them. The watchmaker affixes the movement in the case with several tiny clamps and screws. Then he closes up the back for the last time. After checking that the movement works properly, he has just one last component to assemble to the watch head. This particular watch company has developed a unique protective device which goes over the crown. A computer-guided mill shapes it out of the same type of metal as the case, so that aesthetically, it blends seamlessly. The watchmaker screws the device to the case, so that it bridges the crown. The device has a lever, the tension of which the watchmaker carefully adjusts with the help of this gauge. The lever closes the device tightly over the crown, immobilizing the crown so that it can't be turned accidentally. Finally, they mount the watch head on an automated machine which closes the back tightly. This is critical for water resistance. Every single watch head this factory manufactures must pass several quality control tests to ensure timekeeping accuracy and water resistance. For water resistance, they first test using air pressure. Then, actual water tests. First, a low-pressure test in 10 centimeters of water. Then, a high-pressure test in 375 meters of water, which far exceeds the 300-meter depth to which the watch is guaranteed to be water-resistant. Finally, it's time to assemble and attach the watch strap, either a link bracelet in matching metal or a strap made of fine leather, a fitting finale to this luxury wristwatch, the elegant product of precision technology and time-honored tradition.